So in section 3.8, we start looking at some of the properties and the different classes of ionic compounds. So the thing about ionic compounds is that there are no molecules present. What we have instead is a crystal where we have a repeating pattern of positive and negative ions. And the ions are organized in a way that they maximize attraction between the oppositely charged ions and minimize repulsion between the ions with the same charge. So if we zoom in on a little bit of this rock salt structure here, you can see that the green, these are sodium ions, Na pluses, and the blue chloride ions are always along the edge of this little square, whereas the ions with the same charge, in this case I'm picking out two blue ones, are along the hypotenuse from each other. And as you remember from high school geometry, the hypotenuse is always longer than the edge. So in this way, the ions that are repelling from one another are kept further away from each other than the ions which are attracting one another. So that's it, right? Now, in this kind of structure, there will be the appropriate number of each kind of ion in order to achieve electrical neutrality. And in this case, there are equal number of the single positively charged sodium ions and the single positively charged negative chloride ions. The ionic bond is very, very strong. So typically, ionic compounds have a lot higher melting points than molecular compounds. And in fact, all ionic compounds are solids at room temperature and have high melting points. Just to reiterate, in ionic compounds, there are no molecules. What we have is an approximately infinitely repeating network of positive and negative ions arranged in what we call a crystal. The formula of an ionic compound, what we call the formula unit, doesn't represent a molecular structure. What it represents is the smallest whole number ratio of ions that gives you electrical neutrality. And that's an important concept. So there's a little bit of vocab that is associated with ionic compounds. And some of this is related to the terms acids and bases. So acids are compounds that form hydrogen ions, and bases are ionic compounds that contain either the hydroxide ion, OH-, or the oxide ion, O2-. Now, I tend not to use these terms that much in this particular class. A term that I will use quite a bit is salts. And salts is just another way of saying, if you say that something is a salt, it's the same as saying that it is an ionic compound. Okay? It's the same thing. If something is described as a salt, that just means it's an ionic compound. Okay, so that concludes this very short video on properties and types of ionic compounds.